Okay, video number 2. It's problem 2 on page 74. We start with our function that's given at the top, f of x equals x squared over the absolute value of x for x doesn't equal 0, and it equals 0 for x equals 0. Now the problem states, let f be the continuous function defined above. What is the value of the integral of -4 to 2 of f of x dx? Okay, so we need a little explanation here. Basically, we have something strange happening at 0. So my first thought is I should break up my integral from -4 to 0 and 0 to 2, and I'll explain that why. So let's say -4 to 0 of f of x dx plus 0 to 2 f of x dx. And this is just the property of integral. The integral from -4 to 2 of f of x dx is the same thing as saying -4 to 0 of f of x dx plus 0 to 2 of f of x dx. I'm just breaking up the region into two separate regions. Now, the question is, this first integral is going to be when when x is negative, right, -4 to 0, and this is going to be when x is positive from 0 to 2. Okay? Now, my question is, what is the behavior of this function when x is negative? Well, in order to understand this, we have to understand the behavior of an absolute value function. Okay, so if I were to take the absolute value of -3, that equals +3. So the absolute value of x is equal to -x when x is less than 0, right? Basically what this is saying is, if x is less than 0, the absolute value makes me switch signs. So if x is -3, like it is here, I end up with -3, negative of -3, which ends up as +3. Okay? So when x is negative, the absolute value of x is actually equal to -x. So what I'm going to do for this integral, since I'm only operating in my -x region, I'll actually turn this x squared over absolute value of x into, from -4 to 0, that becomes x squared over absolute value of x equals -x dx, right? Plus, now let's talk about when the absolute value of x is positive. Well, the absolute value of just +3 equals 3. So therefore, the absolute value of x equals x when x is greater than or equal to 0. Okay? So, and this one above is true for when x is less than 0, because the absolute value of 0 is -0 and +0. It makes no difference. So, just to kind of throw that in there. But let's just look at this. The absolute value of x equals x when x is greater than or equal to 0, right? Absolute value of 3 just equals 3. So for the positive region, 0 to 2, I can take my integral, my f of x becomes x squared over just regular x. So that becomes x squared over x dx. Now what I'm going to do is I'll simplify this integral, and this becomes the integral from -4 to 0 of x squared over -x becomes -x dx. And here my integral becomes from 0 to 2, 0 to 2, x squared over x is just x dx. Okay? Now I can just take these integrals, right? The integral of -x is x squared over 2, or it's better, right? -1/2 x squared from -4 to 0, plus the integral of x is just 1/2 x squared from 0 to 2. Okay, now I'm going to erase this top bit just so I can keep going. Now, I suppose I shouldn't erase that. F of x equals, the question is f of x equals what? F of x equals 0 for x equals 0. I'll just put that up there because that's going to become important in a second. Remember this, because in the thing it says f of x equals that function for when x does not equal 0, but it equals 0 for when x equals 0. So I know that when I'm evaluating these at 0, this just applies, right? I'm just plugging in 0 here. Okay, so that was kind of confusing. Don't worry about it too much. Just evaluate your integrals. So negative 1/2 x squared from negative 4 to 0 plus 1/2 x squared from 0 to 2. Okay, so I'm just evaluating, plugging in 0, obviously this is going to be 0. So then it would be 0 minus, in parentheses, negative 1/2 x squared, so it's negative 4 squared, plus, evaluating this at 2, 1/2 2 squared.